Hey everybody, it's Jane from Norman S. Wright. Let's continue talking about boilers. So today's topic is going to be condensing boilers and how they work. Let's get started. So before we look at how condensing boilers work, let's quickly return to the basic boiler operation. Let's start with a water tube boiler. So I'm going to put the burner over here, and we have the water tube with cold water in here and hot water going out here, surrounded by the hot gas. In last week's video, I didn't draw the flue exhaust, so let's put that up here. The water tube boiler has tubes of water that are heated by the surrounding hot gas. This is a non-condensing boiler. A condensing boiler makes use of the flue exhaust before it's exhausted out of the boiler. All boilers are actually condensing boilers depending on the return, or as I'm drawing it here, the cold water temperature. If the cold water temperature is below 127 degrees Fahrenheit, which is the dew point of the flue gases, then it will condense. I'll come back to that in a minute. I think I need to make a little more room. Let's just draw the outside, and we'll put the burner over here. We'll have the cold water come in here, and then the hot water will go out this side. So now all of this is hot gas that surrounds the water tube. And then I'll put the flue exhaust over here. So as the cold water comes in, it passes through the flue exhaust. The condensing boiler removes the latent heat, the moisture, from the hot flue gas, causing water to condense out of it. The moisture collects at the bottom and is drained out of the boiler. Now let's make a little more room and talk about condensing fire tube boilers, which you're more likely to see. Let's draw a burner at top. This is more or less the image we did last time, where inside this orange are the hot flue gases, and around the outside is the water. So let's put the cold water in here and have the hot water come out here. Inside the fire tubes, the condensing boiler removes the latent heat, again the moisture, from the hot flue gases, causing water to condense out of it. It drains down into an area at the bottom and is collected and drained out. Condensing boilers are more efficient than non-condensing boilers because they essentially recycle the waste heat in the flue to preheat the cold water entering the boiler. This process captures up to about 8,000 BTU of heat per gallon of condensate, which can be up to 12% of the original fuel energy cost. So there's a significant potential for energy savings using condensing boilers. So let's move this over because I want to discuss one more thing, that is corrosion. If you remember from last week's video, I said that traditionally designed boilers operate without condensing the flue gas in the boiler to prevent corrosion of parts. And I just said that all boilers are basically condensing boilers because the difference comes down to the water temperature. I said that flue gases condense below 127 degrees Fahrenheit. So if the return water, which I've been drawing as cold water, is below 127 degrees Fahrenheit, you will have a condensing boiler. Flue gas condensate is acidic though, so condensing boilers are designed to withstand the acidic condensate, usually because they're constructed of stainless steel. So it's important to remember that any fuel-fired boiler could experience condensation, and if they're not designed for it, their construction materials can corrode when exposed to the flue gas condensate. So let's bring all this back on screen. So that's a quick overview on condensing boilers and how they work. Don't forget to like and subscribe to our YouTube channel, and thanks for watching.